AI model, DNN for semiconductor PPC, math formulas per node and DNN processing for output. In-depth explanation, AI engine, DNN for semiconductor PPC, math formulas per node. Pushpin title of the diagram. AI engine, DNN for semiconductor PPC, math formulas per node. Large blue diamond author, Pradeep K. Suri, author, researcher, and AI/ML architect. This is a deep neural network, DNN, visual representation used to predict, optimize, and control production planning and control, PPC, in the semiconductor manufacturing industry, enriched with mathematical logic and formulas at each node. Brain 1. Architecture overview. Layer description. Know of nodes. Math branch involved. Input. Real-world semiconductor process inputs 8 arithmetic, algebra, statistics, thermodynamics. Hidden 1 to 4 processing and transformation layers. 6 rightward arrow, 5 rightward arrow, 4 rightward arrow, 3 linear algebra, sigma, wx plus b. Output. Predictive and actionable business KPIs. 10 algebra, statistics, time series. Inbox tray 2. Input layer, blue nodes, data from factory floor. Each node represents a sensor or ERP-derived parameter with its mathematical formula and corresponding maths branch. Node formula description. Math branch. Raw material cost sigma, quantity times rate, total value of raw inputs arithmetic. Manpower hours sigma, shift times staff, total labor effort algebra. Energy usage P times T, power times time arithmetic plus physics. Machine hours runtime times machines operational time algebra. Process time sigma, step durations task by task timing arithmetic. Ambient temp delta Q slash MC, heat flow formula thermodynamics. Tool change F, cycles, based on usage cycles probability. QC sample size square root and statistical sampling law statistics. Puzzle piece purpose, these values are fed into the model for predictive processing. Counterclockwise arrows. Button 3. Hidden layers, orange, green, violet, cyan, processing with activation functions. Every node is labeled. Sigma, wx plus b, rightward arrow the sigmoid, or any other, activation function applied on weighted sum plus bias. Math branch, linear algebra. Matrix multiplication, wx. Bias addition, b. Activation transformation, sigma. These layers extract features, detect patterns, and compress multidimensional dependencies into meaningful signals. Brain interpretation. These transformations abstract nonlinear behaviors in manufacturing, machine interactions, operator efficiency impact, tool wear effect on QC, etc. Outbox tray 4. Output layer, yellow nodes, predictions and KPIs. Each output node is labeled with a KPI computation formula and its mathematical domain. Output formula business meaning math branch. Raw mat, Indian rupee Al, sigma quantity times cost resource valuation arithmetic. FG units sigma, batch times yield, output prediction algebra. Dispatch sigma shipped units outgoing stock arithmetic. Feedback sigma rating divided by hashtag clients customer sentiment statistics. QC pass, percent. Pass divided by total times 100 quality success rate ratio. WIP, RM input, used inventory tracking algebra. WIP, prod sigma stage output real-time flow tracking process engineering. WIP, FG prod, dispatch final stage stock arithmetic. Yield, percent. Good divided by total times 100 production efficiency statistics. Downtime sigma breakdown time reliability metric time series. Rocket purpose, these are actionable outputs for top management, profit impact, customer feedback. Middle management, inventory, efficiency. Operations, machine downtime, QC status. Bar chart 5. Key features. Feature value. Artist palette color-coded layers. Each layer has its own vibrant color for clarity. Triangular ruler formula as label. Every node reflects its formula plus math branch. Puzzle piece interconnected lines show neuron connections rightward arrow feature extraction path. New Moon dark theme optimized for dashboards or presentations. Brain educational view shows how AI plus math drive industrial intelligence. Brain summary, what makes this an AI engine? 1. Interdisciplinary knowledge, combines engineering, math, statistics, and AI. 2. Mathematical traceability, each prediction is formula-backed and auditable. 3. Neural abstraction, hidden layers transform raw signals to intelligence. 4. Decision-driven outputs, KPIs directly support ERP, MES, or SCADA systems. 5. Real-world application, specifically built for semiconductor manufacturing industry PPC. Puzzle piece optional extensions, if needed. White heavy checkmark integrate with live factory data, example OPC UA or SQL feed. Chart increasing add real-time bar/pie chart dashboards. Repeat button build reverse DNN for root cause prediction. Inbox tray export layout as interactive HTML for management. Bar chart advantage of the Sankey diagram, AI engine for semiconductor PPC. Model by Pradeep K. Suri, author, researcher, and AI/ML architect. The Sankey diagram you've created provides a powerful visualization of flow-based intelligence in the context of AI-driven decision-making for production planning and control, PPC, in the semiconductor industry. White heavy checkmark 1. Visual flow of AI decision-making. The diagram shows how each input factor, on the left, contributes to the final KPI outcomes, on the right, through sequential hidden layers of a deep neural network, DNN. Each band thickness represents influence magnitude, uniform here, but can be weighted in advanced models. White heavy checkmark 2. Layer-wise transparency of DNN. Instead of treating the DNN as a black box, this view clarifies the internal processing. Input layer, light bulb sensors, ERP data. Hidden layers, repeat button AI computation and abstraction. Output layer, chart increasing business outcomes and KPIs. White heavy checkmark 3. Stakeholder communication. Top management can see how raw materials and energy usage eventually affect business KPIs like yield, dispatch, and downtime. Middle management gains clarity on how parameters like tool change frequency or ambient temperature influence QC and WIP metrics. Operational teams benefit by knowing which inputs are critical for specific outputs, supporting data-driven troubleshooting. White heavy checkmark 4. Advantage over bar/line charts. Metric Sankey diagram bar/line chart. Flow relationships white heavy checkmark clearly shown crossmark not visible. Layered AI processing white heavy checkmark transparent crossmark abstract. System-wide view white heavy checkmark end-to-end visibility crossmark isolated measurements. Input-output mapping white heavy checkmark directly traceable crossmark needs manual interpretation. Useful for management white heavy checkmark strategy and explanation white heavy checkmark only metric comparison. White heavy checkmark 5. Real applications in semiconductor PPC. Monitor energy heavy operations, energy usage rightward arrow downtime. Predict yield based on process conditions, ambient temp rightward arrow yield. Optimize manpower and tool usage, manpower hours plus tool change rightward arrow QC pass %. Minimize WIP bottlenecks, machine hours rightward arrow WIP FG rightward arrow dispatch. White heavy checkmark 6. AI education and audit ready. This diagram also serves as Book's educational tool, for AI teams, interns, and executives. White heavy checkmark audit trail, shows traceability from input to prediction, aiding AI model transparency and explainability, XAI. Repeat button optional enhancements. Weight the links by influence from actual model, example SHAP values, or LIME. Animate or interact with dash to show live flows. Export as HTML or integrate with KPI dashboard. Brain AI engine, department-wise input, processing and output via DNN, semiconductor industry. Model author, Pradeep K. Suri, author, researcher, and AI/ML architect. The DNN diagram shown visually represents how each department's data feeds into the AI engine, is mathematically processed through hidden layers, and results in key semiconductor manufacturing outputs. Let's break it down department by department. Large blue diamond 1. Department-wise inputs, blue nodes. Department input node description formula / math branch. Procurement raw material cost sigma, quantity times rate, arithmetic. HR / production manpower hours sigma, shift times staff, algebra. Utilities energy usage power times time, P times T, physics. Maintenance machine hours runtime times #machines algebra. Production process time sigma step durations arithmetic. Environment ambient temperature delta Q / MC, thermodynamics. Maintenance tool change frequency F, cycles, probability. Quality QC sample size square root and statistics. Right arrow each department provides structured and quantifiable input that flows into the AI model. Counterclockwise arrows button 2. Hidden layers, orange, green, violet, cyan, AI engine core processing. Every hidden node is labeled. Sigma, Wx plus B, linear algebra. This signifies matrix multiplication of weights and inputs, Wx. Bias adjustment, B. Nonlinear transformation via activation function, sigma. These layers are responsible for feature extraction, noise filtering, hidden pattern discovery. Lightbulb. Think of this as the AI brain making sense of cross-departmental data and finding non-obvious correlations like how ambient temperature affects yield, how manpower hours influence WIP and dispatch efficiency. Yellow circle 3. Output layer, yellow nodes, department-wise KPIs and reports. Output node business department formula and interpretation. Raw material, Indian rupee L, procurement sigma quantity times cost arithmetic. Finished goods, units, production planning sigma batch times yield algebra. Dispatch, units, logistics / shipping sigma shipped units arithmetic. Client feedback customer service sigma rating divided by client's statistics. QC pass, %. Quality assurance pass divided by total times 100 ratio. WIP, raw material stores / inventory input, used algebra. WIP, in production shop floor sigma stage outputs process engineering. WIP, finished goods FG stores prod, dispatch arithmetic. Yield, %. Production and QA good divided by total times 100 statistics. Downtime, HRS, maintenance / TPM sigma breakdown duration time series. Chart increasing for department-wise AI reports and graph suggestions. Department key graph / reports AI use case. Procurement raw material cost vs yield graph predict supplier impact on yield. HR / production manpower hours vs output graph optimize shift allocation. Utilities energy usage vs FG output forecast power efficiency. Maintenance tool change vs QC failures predictive maintenance. Production process time vs yield graph bottleneck identification. Environment ambient temp vs downtime correlation heat map climate control efficiency. Quality assurance QC sample size vs QC pass % optimize inspection policy. Logistics dispatch trend line, WIP vs dispatch scatter plot fulfillment risk prediction. Stores, RM/FG, WIP raw /FG bar charts, inventory optimization dashboard stock flow optimization. Wrench technical summary. Brain DNN layers simulate human decision making. Bar chart each output can be linked to Sankey diagrams, forecast dashboards, or risk maps. Chart increasing time series plus classification plus regression models combined inside the DNN. Rocket final words. This DNN-based model unifies cross-department data, applies domain-specific math logic, outputs actionable KPIs for decision makers. Would you like a multi-tab dash app for real-time graph monitoring? Thank you.